Hello everyone, welcome to Alfonso Academy. I am Sir Peter Alfonso and this is the fifth part of chapter Gravitation. So to start with, we will see what is mass. Mass is the amount of matter present in the object. Anything which occupies space is called matter, and the amount of matter present in the object, it is called as mass. So its SI unit is kg, that means it is measured in kilograms. And then it is a scalar quantity, that means it has only magnitude and it has no direction. Its value is same everywhere. That means even if you go on some other planet, the value of mass, the magnitude of mass will remain the same. It will not change. It will be constant. And then according to Newton's first law of motion, it is said to be mass is the measure of its inertia. Higher the mass, higher is the inertia. Inertia is of course the tendency of a body to resist a change, or a tendency of a body to maintain its original state of rest or of motion. So higher the mass, higher is the inertia. And then the weight. The weight of an object is defined as the force with which the earth attracts the object. That means weight is equal to force. It is nothing but the force with which the earth attracts the object of certain mass. So weight is equal to force, and force is equal to mass into acceleration due to gravity. By looking at the formula, you can see that weight is dependent on acceleration due to gravity. Mass is constant, so weight is dependent on acceleration due to gravity, and small g varies from place to place. At the equator it is different, at the poles it is different, to a certain depth it is different. If you consider go to a certain height, then it goes on decreasing. On other planets and satellite, there also g varies. So as the value of g is not same everywhere, the weight of the object changes from place to place. Because g varies, weight varies. So weight doesn't remain same like the mass. Mass remains same, it is constant, but weight changes from place to place. Now if you consider Shantaram's mass as 50 kg, his weight will be 50 kg into 9.8 on surface of the earth. That means 50 kg into 9.8, which is equal to 490 Newton. This is the actual weight of Shantaram. When we talk about 50 kg, it is his mass. This is his mass, but weight is 490 newtons. So in our day-to-day life, we use the same unit for mass and weight, which is kg. But scientifically, unit for mass is kg and unit for weight is Newton. So if we take an example of 1 kg of sugar, it is the mass of that sugar. But weight will be 1 kg into 9.8 meter per second square, which will be equal to 9.8 Newton. This is the weight of 1 kg of mass. So next, there is a question asked on your book. Will your weight remain constant if you are going above the surface of the earth? Answer is no, it will not remain constant. It will go on decreasing, because as you are going above the surface of the earth, acceleration due to gravity goes on decreasing. So if g decreases, weight also decreases. Next question is, if you are standing on a very tall ladder and your distance from the center of the earth is 2 times the radius of the earth, so r becomes 2r. Substitute that in the force formula. Instead of 2r, you have to substitute 2 times capital R, 2 times the radius of the earth. So you will get in the denominator as 4, 1 by 4. So this is actual formula for force, the actual weight on the earth's surface. So weight on the surface of the earth divided by 4. So your weight becomes 4 times less than the actual weight on the earth, if suppose you are at the distance of 2r from the center of the earth. So next, there is a solved example given on your textbook. On your textbook, it is solved a bit different way in a ratio form, so it might be complicated for you. I have made it little simpler over here. Let's see. So if a person weighs 750 Newton on earth, how much would be his weight on the moon? Given that moon's mass is 1 by 81 that of the earth and its radius is 1.1 by 3.7 of that of the earth. So firstly it is given there is a person who weighs 750 Newton on earth. You are told to find his weight on the moon, and 2 relations are given, that mass of the moon is 1 by 81 times that of the mass of the earth. And second relation is given, radius of moon is 1 by 3.7 that of the radius of the earth. So it is straightforward given. You can, it is like copy and paste over here. It's very simple. See, moon's mass means mass of the moon is 1 by 81 times that of the mass of the earth. And second, radius of the moon is 1 by 3.7 that of the radius of the earth. So these are the two relations which are given. Now you can write the formulas on two places. One is on the moon, one is on the earth. So weight of the person on earth is gm. Me means mass of the earth into mass of the person divided by radius of the earth square. Now mass of the person will remain constant on the moon and on the earth. It will remain small m on both the places, moon and the earth. And g will also remain constant, which is universal gravitational constant. It applies for full universe. So next, weight of earth is given as 750 Newton. G will remain the same. This full thing will remain the same. Now you can find the value for mass of the person. So mass of the person you can keep one side and rest of the things you can bring other side. So this Re square will go in the numerator and Gme will come in the denominator. Mark that equation as 1. Now write the formula for moon. Weight on the moon. Weight on the moon is equal to G, mass of the moon, multiplied by mass of the person, Rm square, which is radius of the moon square. And now substitute the formula for m, which is over here from 1. Substitute equation 1 in this equation. So instead of m, you will put this value 750 Re square divided by Gme. This is the value for instead of m. So now you have this full. Now go for the relations, two relations. What is given? Radius of the moon is given, one relation, and mass of the moon is given. So mass of the moon you can substitute over here. 1 by 81 times me. 1 by 81 times me. And radius of the moon 1 by 3.7 Re. 1 by 3.7 Re and this square. So you are substituting radius of the moon as 1 by 3.7 Re, the whole square. Now you can solve it. This will come in the denominator 1 by 81 and then this 3.7 will go in the numerator as 3.7 square because there is a square over here. And this square will also go for this Re square. Then Me will remain in the numerator and this value will remain on the same place. Now you can cancel. You can cancel Me. You can cancel Re square. Now only constants will remain. The numbers will remain. Then you can multiply and divide. So 750 divided by 81 I have done over here. 750 divided by 81. So for that value I am getting as 9.259. 9.259. And then 3.7 the whole square. 3.7 whole square. That means 3.7 multiplied by 3.7. For that I am getting as 13.69. So 13.69. Now you can put the unit, Newton, which is the unit for weight or the force. And next you can multiply this, you will get this value. I have shown the multiplication over here. It's big multiplication but it's easy if your maths is good. So 126.75. So this 75 I have rounded it to 8. So 126.8 Newton is the answer for the weight. Now if you can see this value which you are getting for weight is the weight of the person on the moon. Weight of the person on earth was 750 Newton. Weight of the person on moon is 126.8 Newton. Now if you compare the weights and divide and see 750 divided by 126.8, then you will find that weight of the person on the moon is less as compared to the weight of the person on the earth by a ratio of 1 by 6. 1 by 6. So if you multiply weight of the person on the moon into 6, then you will get the weight of the person on the earth. That means the gravitational force which is acting on the person on the moon is less as compared to that of the earth. So the acceleration due to gravity on the moon is 1/6 times the acceleration due to gravity on the earth. So this is the relation which we are getting through this problem. 71% of our earth's surface is covered by water, and you must be knowing about the high tides and the low tides which occur regularly in the sea. The level of sea water at a given location along a seashore decreases or increases twice a day with regular intervals. So the low tide and high tide occurs every after 6 hours 13 minutes, and it has a reason. The level of water in the sea changes because of the gravitational force exerted by the moon. Every object attracts every other object with definite force. So just like the earth have its own gravitational force of attraction, moon also has its own gravitational force of attraction, and the effect can be seen over here. The water which is directly under the moon rises, water level rises over there, causing a high tide. So water directly under the moon gets pulled towards the moon, and the level of water rises at that part, causing a high tide. Reason is simple: gravitational force of attraction of the moon. So the water from the areas which are perpendicular to this area where the water rises gets moved towards the area under the moon. So the moon's gravity affects mainly till the center of the earth. Now this is the center of the earth. The gravitational force of the moon, the effect of that gravity is only till the center of the earth. So therefore the water in front of the moon side pulls more outside. So the water which is here right in front of the moon, because of the gravitational force of the moon, will get more pulled towards outside, and due to the stretch there is a pressure on both the parts. Now there is a stretch which is produced because of the gravitational force of the moon. There is a stretch produced, more water has moved to this part, and that is called to be a stretch. So there is a pressure which is created over there, and because of that water on the other side of the moon is also pulled. So water on the other side is also pulled because of the stretch and pressure created because of the gravitational force of the moon this side. So water gets moved this side also from the places which are 90 degree from this place where there is a gravitational pull. So water from here gets moved on both the sides, creating high tides on both the sides. But the high tide over here is slightly more as compared to here. Low tide or the high tide occurs every after 6 hours 13 minutes. So that means this area which is under low tide right now will reach here after 6 hours 13 minutes. It will get high tide. Don't forget, earth rotates. So because of rotation of earth around itself, this area will reach over here after 6 hours 13 minutes and will get high tide. This high tide area will reach over here, it will get low tide. After double time 12 hours 26 minutes, this area will reach over here, again it will get high tide. So if you consider this figure and study this figure nicely, you will get that high tide and low tide occurs twice a day. So 2 times high tide, 2 times low tide. And now don't forget the sun, which is very far from here, because sun is actually very far from the earth, and it seems to be little bit smaller, but it is very huge in mass. It has a very high gravitational force of attraction also, but the effect of gravitational force of attraction on earth is very less because it is very far. But when that gravitational force of attraction gets added with the gravitational force of attraction with of the moon, so when both the forces are added, then there is a effect on earth. Effect can be seen on the earth. The water level rises to a greater extent. So when moon, sun and earth are in one line, effect can be seen. You can see a very little bit extra high tide. So when the sun, moon and the earth are in straight line, a lot of drag is nothing but the water is pulled to a greater extent. Lot of drag is created and the highest tide occurs on the part. You can see a extra tide. Highest tide occurs on the part, that is on the full moon day or on the no moon day, when all three, earth, moon and sun, are in one line. If you take a stone and drop it into water, there is formation of waves, and that is why water moves. If you take a string or a guitar and play the string, then there is formation of waves. When you are talking with your friend can hear you talking, because the sound travels in the form of waves. When the light travels from astronomical objects like sun, it travels in the form of electromagnetic waves. There are different types of electromagnetic waves like gamma rays, ultraviolet rays, infrared rays, radio waves, microwaves, and then comes the gravitational waves. These are different types of waves and these are very weak waves. So they have been called the waves on the fabric of space-time. Albert Einstein predicted their existence in the year 1916. These waves are very weak, this we know, and it is very difficult to detect them. So since they are very weak, it is difficult to detect these waves. But there is one instrument which is used to detect these waves. So LIGO, which means Laser Interferometric Gravitational Wave Observatory. So it is an instrument to detect these waves which are coming from astronomical sources. Of course, these astronomical sources are in our space. So this discovery has opened a new path to obtain information about the universe. So we can study our universe in a better way. Gravitational waves are ripples in space-time caused by some of the most violent and energetic processes in the universe. So these gravitational waves are ripples. These are waves which are caused because of different events which occur in our universe. So the strongest waves are produced by events such as colliding of black holes, when there is massive stars exploding at the end of their lifetimes, or there are any accidents in the space. That time these gravitational waves are very strong. So that's it in this part. This was the 5th part of chapter Gravitation. Hope you have understood everything. If you have not understood anything, then please post a comment in the comment box. I'll definitely reply your questions or queries. And then next part, the 6th part of chapter Gravitation, will be studying about free fall and we'll solve some numericals. So thank you very much for watching. Please subscribe my channel, like it and share it. Thank you very much.